Hello. Um, I realize it's been a while. You heard anything from me, but well, you know, um, I have suffered these last 2 weeks from a inflamed nerve in my left arm, which well, and it's still going on, and it's giving me a hell of a lot of pain. So, for these last 2 weeks, I hardly found any energy to continue work, either on the Orion chassis you're seeing right now, or anything else. However, the pain being somewhat less today, I decided to make a short update of the ongoing work on the Orion chassis. Now, you'll remember that the previous episode I succeeded in eliciting a little bit of sound from the radio. But unfortunately, this rapidly degraded. Actually, the radio right now only produces a kind of white noise and or crackling. Now, I think I've isolated the problem to a specific part of the chassis, and more precisely to the tuning capacitor, which you see here. Now, it turns out that the plates of the tuning capacitor, so these plates here, which can move, so as you see, if I turn the tuning knob, those plates move. And you see that the plates of the mobile part of the tuning capacitor, so this part, slot into a fixed part which is on the right hand side. Now, this is a capacitor, and the plates of these tuning capacitors should never make contact with one another. Obviously, the dielectric, so the insulation between the plates, not being plastic or anything, but simply air. So, if you measure the resistance of tuning capacitor plates, so between the fixed and the movable plates of the tuning capacitor, you should be getting infinite in the best of cases. Now, when I measure resistance between the plates, it measures, well, unfortunately, quite close to zero, which means that there is a short between the plates, and that, of course, is not good. It's effectively producing a short circuit in the radio, which in turn, when you try to tune the radio, produces either loud crackling or effectively a short circuit in the radio, which if I would leave the radio on for too long, would probably start to destroy it. So I'm trying now to realign these plates in such a way that they do not make contact with the inner plate or the fixed plate, and still allow for a nice fluid movement. Yeah. Now, the problem is that you can't just, well, okay, you could try to bend the plates in such a way gently bend them up or down so that they would not make contact with each other. But that is really, really hard because the spacing between the plates is, well, I'd say never more than a few tenths of a millimeter. So what I resorted to do is actually, if you take a close look at the tuning capacitor, you see right here that you see these screws here, these tiny screws here and here, two there, and two screws here. Now, these hold the movable plates of the tuning capacitor fixed in a fixed position in regard to the axis of the tuning capacitor, this axis here. And it holds the movable plates into such a position that well, ideally speaking, there should always be an air gap between these plates here and the fixed plates over here. Now, normally, I'll tell you honestly, normally you should never mess around with these. But after trying to tinker with gently bending one or other plate, I quickly realized that that would be unworkable. So what I actually did was to release these tiny screws, you see, and readjust the height of this plate assembly in regard to the metal body, so this part here, of the tuning capacitor. Now, I'm telling you, it's an enormously fiddly job. It really needs very, very accurate positioning. So, what you need foremost is a lot of patience. So, if you are armed with a lot of patience, and you do this gently and carefully, you could indeed realign the movable plates in respect to the fixed plates in such a way that there is effectively an air gap between all of them, which of course is exactly what we want. Now, these screws generally are fixed into a certain position by the use of lacquer. So on these screws were dabbed with a spot of white paint lacquer, to lock them into position so that they would never release and or let loose, and the outer axis where the plate to which the plates are attached would never move in regard to the inner axis, which is this one, and so the tuning capacitor would always be accurate. So I took a bit of acetone on a rather hard bristled brush like this, and with the acetone on the brush I gently rubbed away the lacquer which was used to seal the tiny screws into place. After I had done that, I used a specialist steel-tipped screwdriver, a mini screwdriver like this, to release these screws. Now, let me tell you, these screws are truly tiny, and they are very, very short. So if you release them and you screw them out a bit too far, they will simply drop out. So if you decide to go ahead and do this kind of work, then always do it above a flat surface where you can find those screws back easily. Yeah, because if you happen to drop one of these screws, say on the floor, you'll have a heck of a hard time to find them back. And since these screws are rather unique to the assembly on which they are mounted, if you should lose one of them, you'd have a very hard time to replace them. Okay, so that's what I'm doing right now. So I'm trying to position these plates in regard to the fixed plates in such a way that when I take an ohm measurement between the two, I get infinite. Now, I haven't succeeded quite yet, but like I told you, this is really an arduous, long, tedious job. So you better come armed with a lot of patience. And gentleness too, because if you force any of the parts in here, and you completely ruin the tuning capacitor, and therefore you ruin the radio. Okay, I'm going to try to give the Orion a, well, at least for now, a crude aligning. Because honestly, I don't know quite yet how to precisely align the radio, since I have no aligning instructions. Now I'm injecting a 455 kilohertz signal right here, and this, if I'm not mistaken, is pin 1 of the first stage of the first IF stage. Well, I mean pin 1 of the EBF 80, which is in the first IF stage of the radio. Now, so I'm injecting the signal right here. And I'm going to align, or try to align, the radio in the AM band, which might not be that easy, but we're going to give it a try anyway. I set my heat kit RF generator to 455 kilohertz, right there. And I'm injecting the signal, like I told you before, right there, which is pin 1 of the first EBF 80 in the first IF stage. So for good measure, I attached my RF generator to my oscilloscope to check whether the frequency is indeed 450 kilohertz, and it is. So I decided that I would try an alignment procedure, which I did with one of my previous radios, which was, if I'm not mistaken, the Westinghouse, which said that I needed to open the tuning capacitor completely, and it is. And by the way, I did manage to get my tuning capacitor to give infinite. So it's not making contact with ground any longer, or I should say with the fixed plate any longer. So that's perfect. And I set the radio to AM, so I set this switch to AM band, and I'm injecting a modulated signal, I think 300 hertz modulated RF signal of 455 kilohertz, into the first IF stage. And well, depending on how the radio feels, I should say, I can sometimes hear a faint modulation signal, and sometimes I don't. So I'm going to insert this, which is a sort of a plastic screwdriver specifically for turning IF kernels, and I'm going to insert it into the first IF cans channel, which is here, right down there. I don't know if you can see it, but so this channel, and I'm going to tune the IF can until I hope to get a 300 Hz signal coming from the speaker. Okay, so let's just try and give it a go. Yeah. Okay, hang on. Yep. I think you can see what I'm doing, so here we go. It's not that easy. It's quite fiddly actually, because I don't always find the slot by which to turn the kernel. Just checking. Oh, hang on. I thought I heard something. Yeah, I think you can hear a sort of a whistling noise, and that would be, I think, that would be the IF signal. I think, let me see. Aha! There we go. Okay, I'm trying different kinds of alignment tools. Not that easy because the kernel doesn't seem to be quite well aligned in respect to the opening of the IF tube. I decided to open up the IF cans because it was just too hard to find out what I need to do to align them, and so I had to take off the aluminum cans which covered them, and as you can see, it's just plain aluminium. It's a cylindrical can, and you can see a piece of cardboard inside, which I suppose is inside to avoid the contacts you see over there, to get in touch with these inner sides of the IF cans cover. So okay, it was a bit of a hassle, because you can see these little slots. Yeah, there are two slots, one diametrically opposed to the other. Yeah. Now in those slots were mounted these little screws. So let me just take one and show you. So this little screw was mounted inside the slot you saw in the can, and on the other side, the screw end of this little gripper plate you see on top goes through the chassis and is bolted down onto the chassis with a small nut. So I had to release the nuts, and then I simply had to pull up the can to uncover the IF coils. Now, mind you, there was a little trick to it. Normally, you'd expect the can to just come off. You just would pull it off like that. But it turns out the can was bent inwards here and here, and that gripped the base of the IF coil, this plastic base over here, which is well, a kind of a clear plastic. Anyway, I pulled off the cans, and well, the good thing is I can clean the cans thoroughly now, and so I can also clean the inside of the IF coils. Also, there are capacitors inside the IF coils, and I'll measure them, and if they measure bad, I can replace them now, which is sort of a silver lining to all the trouble I had to go through to unmount these bloody IF cans. Now there's one little interesting detail. You can see the IF can has an off-center hole here. Now it turns out that that off-center hole has absolutely no function whatsoever. At least not a mechanical one. The only thing I can imagine why this off-center hole is in the can is to allow heat dissipation coming from below the chassis and exiting the can through this little hole. But that's really the only thing I can imagine, the only reason I can imagine you'd have a small off-center hole. So there are no screws or anything which are set in respect to this little hole. So that's it for now. Well, now I'm going to see whether I can turn the kernels inside the IF coils, and when and if I can, then I'll continue this update. I unfortunately had to clean out the tops of the IF coils, and as you can see down there, well, it's pretty small, so I'll try to give you a close-up. Down there you see the core of the IF coil, which has been cleaned from any crud that was left in it. Apparently they had filled up these core tubes with, well, I'd say a kind of wax perhaps, and I had to clean it out piece by small piece with the help of my surgical knife. So I think you all know what I'm talking about, but I'll show it to you to give you an idea. Hang on. Ah, there it is. Okay, so with the help of this surgical knife, I managed to dig out that wax that was set inside the tube with the tip of my surgical knife, which, as you all know, is quite sharp and all. So now that the coils, or rather the kernels of the IF coils are free, I can start the alignment operation once again. Well, here I am, and I'm a bit stranded. In fact, I'm stranded for two reasons. The first reason is that for some inexplicable reason, the kernels of the IF coils, of IF coil assemblies, and more specifically the upper kernels, are stuck, and they are stuck good. And I dare not put more force on the whole assembly than necessary, because the assembly is already in not too good a shape. So if I'm going to put too much force on it, I might break it, and then, well, then I'd have even more problems than I already have. So until I find a way to unblock the kernels which are stuck up here, you can see them as that darkening of the tubes. Yeah. As long as I don't find a way to gently unstuck them, I just can't give the chassis an alignment. So I will need a bit more time to find a solution. Now the second problem is that, well, I really have too much pain. So continuing work on the chassis is a bit too hard right now. So unfortunately, I think I will have to call it quits for tonight. As soon as I find a solution for unblocking the kernels, I'll be back with another update on this chassis, on the Orion chassis. I might continue another project, I don't know yet. It will largely depend on how I feel. So unfortunately, that's it for now. Thank you for watching, and I hope to be back soon with another update. So stay tuned.